Last year on March 5th, a 100-pound piece of equipment fell on one of our firefighters at McCord Air Force Base. This caused him to have a severe neck injury and took him away from our mission for 30 days. We designed a latch, as you see in front of you, to prevent this from happening again in the future. This latch took us almost 3 weeks to design from start to finish. But with additive manufacturing and vehicle maintenance, that time can be cut down all the way into a single day. With additive manufacturing, this would also minimize downtime for other parts, such as obsolete parts, and in this case, a non-existent part. We are not limited to one specific material, kind of like 3D printing. It's the same process as 3D printing, but with today's technology and in additive manufacturing, this opens up a whole new realm and we'll be able to print in steels and metals such as aluminum and even titanium. These kits, like the one you see in the picture behind us, can be rolled out and very quick and easy to move. The one that is in the picture can be set up and you can begin printing within minutes. You know Red Horse units will love that.
We're not the first ones in the industry to do this. Industry leaders such as Ford, they produce over 500,000 parts a day. Parts such as engine covers on their Ford Mustangs. Boeing, they save an average of $2.5 million per Dreamliner aircraft. General Electric, they produce over 85,000 fuel nozzles for aviation use. A part that was over 25 pieces individually welded is now one single part with additive manufacturing. Lockheed Martin, a main partner in the military today, they took a part for the C-5 aircraft that would take over 52 weeks to manufacture, and they brought that down to 1 to 2 days. What we're asking for today is $350,000. This would get us a 3D printer. It'll also provide us with the training and certifications to teach other individuals. In addition to that, it'd provide us with the software and the maintenance, so we don't have to worry about that. Finally, it'll provide us with the proper materials in order to create our latches.
Our mission achievement comes in 3 phases. The first phase, we would like to purchase the equipment and the required software to get us off the ground and up and running. We would also have to start combating our vehicle maintenance technical orders. The second phase, we would like to begin printing our latch and other obsolete parts in vehicle maintenance. However, we would have to validate those parts and make sure they're up to manufacturer's specifications. The third and final phase, we would like to eventually print anywhere on demand, and even for other organizations such as MXS and AMXS, because they would love to benefit from this additive manufacturing process. Right now, the average age for each Air Force vehicle in the fleet is 13 years old. Federal law states that manufacturers don't have to supply parts for these after 10 years. This is a huge problem that we have in vehicle maintenance. We're always fumbling around looking for parts, and sometimes we can't even get them anymore, so we have to have them custom made for us. This is usually very expensive and we'll have to wait weeks, if not months. With additive manufacturing and vehicle maintenance, we'd be able to streamline this process and start making these parts in-house at facilities, and we'd be able to get these vehicles back to the customer faster than ever.
0 injuries have occurred since we implemented our latch at McCord Air Force Base. We have multiple partners who have awarded us and recognized us for our innovation and are ready to bring it to the next level. We have multiple suppliers such as Mark Forge and Fabric Labs who are ready to partner with the Air Force today. As soon as we receive our 3D printer, we're able to print right away, getting all of our latches Air Force wide to all 904 structural fire trucks, thus preventing any further injury. We'd like to thank you for your time and this opportunity today. At this time, we'd like to ask if you have any further questions.
Wow, guys, great. Sergeant Klingerbell, Airman Bessie, that was phenomenal. I mean, short, sweet, easy. I know exactly what you're looking for. You've printed these latches. You found a problem. You said, how do I fix it? How do I get it? How many of these latches do you have on the fire trucks today?
So currently there's 2 latches per fire truck.
Okay. And have you installed these on the fire trucks already?
Yes, sir. The ones on McCord Field.
Okay, good. How long did it take you to work through the process to get them on the truck? You know, back through vehicle maintenance or the TO or whatever. You know,
yes, sir.
Are we mature in that? Do we have a good process where what you can design and print we can use and it doesn't take 3 years?
Yes, sir. That's a very good question. So currently, these latches you see here, these were made with the help of Metals Technology on base. However, the first latches that we came up with, they were welded, and those are the ones that we're currently using on these vehicles. And we'd love to use additive manufacturing to slim that process down instead of having to measure each piece out, weld them up, and then make sure they fit the truck.
Right.
And with additive manufacturing, we'd be able to print every every latch the same without having to take the measurements and everything.
So we don't have an added manufacturing part on the truck yet.
No, sir.
What's holding us up?
Additive
And how long?
How long, sir?
What's holding us up from installing one? And how long do you think it'll take to work through that process?
That totally depends on how long it takes to combat our vehicle maintenance technical orders.
That word, man. I wrote that down. Okay, so we're beholden on the TO.
Yes, sir.
You know, we got to go back through that entire process. Do we think that's going to be quick?
Actually, I believe so, because it's very broad, and it even mentions in the technical order that this is a very new technology and they're open for innovation.
Well, you probably got different levels of parts, right?
Yes, sir.
You don't need as much scrutiny, so.
Exactly.
Okay.
So can you walk me through how this would work? I'm not really familiar enough with metal printing, very familiar with plastic and the original development of that capabilities. But it required specifications to be fed in to the computer in order to 3D print it for production and use. When you have an obsolete, outdated part, who is developing the specification for that to feed into the printer itself?
So basically you plug into a scanner into the computer, and then it'll take this part and trace it and get the exact dimensions. Then you upload this to the 3D printer, and then it'll take it and print it within 90% accuracy. And then the second time you scan it again, and the second print will be 100% accurate. Does that answer your question?
Yeah, what about the tensile strength of the metal and all that? Because certain parts are designed to have a higher sustainability rate, whether it's the pressure, torque, heat, things of that nature.
Yes, sir. So we talked with Mark Forge, and for our instance, with our latch, with additive manufacturing, their 3D printed part would be just as strong, if not stronger. With other parts, we'll test the tensile strength based on OEM specifications, and then compare which one, if it meets or exceeds the standards. Does that answer your question?
Yes, sir. Yes, it does. Thank you.
So I guess my question is, you said that there, 900 fire trucks worldwide or in the Air Force, and on average they're 13 years old. So basically the urgency after 10 years is we're on our own, or we're buying something that's very expensive and they kind of have us locked in. So I try to avoid that. That's called vendor lock. So what do you see as scalability? What other types of either vehicles with vehicle maintenance that we could work with, or other types of equipment that are on the ground? So now we're not worried about aircraft going through qualifications testing for them, but something on the ground that you can see utility beyond the firefighting equipment.
That's a very good question. Just about every vehicle in the fleet, especially at McCord, they're getting old, and it's very hard to find those parts. So with additive manufacturing, we'd be able to find a truck that has a solid part, and we'd be able to scan it like Airman Bessie was explaining earlier, and we'd be able to put it on that truck as well. This isn't just limited to this latch for an instant. This is open up for every vehicle and vehicle maintenance, especially if they're getting to be a little bit older. Does that answer your question?
It does. Thank you.
Well, that was super cool technology. I really like it. I've read in the paper or the press that there has been use of this in various locations, both within the Air Force and within the other services. Did you find in your research other applications that might speed up how you would implement this?
Yes, ma'am. So Airman Bessie was speaking about Mark Forge. That's one of the companies that we're currently working with. We actually got with them and we had a nice conference call with them, and the gentleman on the phone, he said that the Marines and the Army are actually using Mark Forge currently today in some of their applications. That picture that we saw, that you can just set it up and go within minutes, that's used for the Army. They use that in some of their training missions.
Super.
Does that answer your question?
Yes, it did. Thanks.
Yeah.
So you guys, you want to come over to contracting? You're doing market research too, so good on you. Awesome.
Thank you.
I tell you, great job, great presentation, guys. Clearly, you're the experts, as I was talking with you a little bit about before, and,
yes, sir.
And thank you for doing that. I want to thank you for seeing a problem and then just getting out there and thinking outside of the box and just trying to fix it and make it safer. So hats off to you guys for that, because you are protecting airmen with your idea. And I think that there's a little bit more research we have to do, things internally with VIMSO and the vehicle folks like that, to make sure we can use this product, but you're definitely on to something, so thank you.
Thank you, sir.
Thank you.
All right, guys, super job. Bessie, look at you, man. Rocking it out. A1C, up briefing us, man. Very good. Sergeant Klingbeil, great mentoring. You know, good job by the team. You know, you guys carried yourself well. We know exactly what you're looking for.
Awesome.
So thanks a lot. Appreciate it. Great job.